Hi, in this project, we will be predicting rankings for countries on the topic of happiness. That is why we will be building a machine learning model on a dataset that has happiness ranking or happiness index. So with me, I have a dataset of happiness index, and with that, we will be training our model and predicting the index itself. Moving forward, what is happiness index? It's an indexation of happiness based on survey results that was first used in the 2012 World Happiness Report. In the survey, the respondents were asked to rate their happiness on a scale of 0 to 10. The happiness index is calculated by averaging the survey results of the respondents. Now, where did it actually originate from? And you might ask why it is actually needed. So, the definition of happiness index originates from the Bhutanese Gross National Happiness Index. Yeah, it might surprise you, but in 1972, Bhutan started prioritizing happiness over other factors such as wealth, comfort, and economic growth. This inspired the Happiness Council to devise their own definition of the happiness index, which was coined in the 2012 World Happiness Report. Now, the details for the project. Now, the project is divided into three parts. The first part being building a machine learning model to predict the happiness rankings or the happiness index. Both of them are the same when I'm telling you or in the context that I'm using. Second, we build a web app or web application on Django to mount the prediction model. Third part, or the last part, is we deploy the Django project on Heroku using or through GitHub. So the machine learning model. So we start off with building a machine learning model using simple linear regression model and train that model using the happiness index dataset. So for this project, we will also be seeing standard scaler in action, or I would say that we will be using standard scaler to standardize our dataset for further processing. And with that, I would also be telling you the reason why I've implemented it also. So the second part is building our Django web app. This is the second part of the course where we will be building the web application using the Django framework. We mount the model we built in the previous part or the first part in this part of the course or project itself. Lastly, there is the last part of the course where we will deploy the Django application on Heroku using the connections to GitHub. So now let's jump on to the first part of this project, that is. So this is the first part of the project where we will be building a machine learning model. Now this is going to be a short video as the dataset I have is pretty straightforward and there is not much hidden data to be extracted also, meaning that the data doesn't contain any categorical data type from which I can extract more information on. But before moving forward, I like to specify that the dataset we are handling is small, meaning our model has to generalize on this particular dataset only. As if it gives poor prediction, then we can't enhance the model by feeding it more data. It sometimes happens that the model that you have predicted, or sorry, the model that you have built is having poor prediction rate, meaning the accuracy is not so high. So what is the first solution that people go for is that they try to feed even more data so that the model is able to understand new and maybe some of the missed patterns and then is able to predict with much better accuracy. But for small data sets or for data sets that are very sparse, we can't do that because once the data set has been exhausted, we can't use it again or we can't even find new data. So for that, we have to make a model that is able to generalize even on the small data set itself. So for that, I will be showing you or specifying some pointers on how to deal with this type of data. Now moving forward, the first thing I am going to do is just mount my drive to the Google Colab so that the Colab can now access the files from my drive directly, which you can see from the first code block here. Next, I'm importing the necessary libraries. So you can see that the libraries that I've imported are all what are used in building a model, pre-processing data, doing feature engineering, maybe feature selection also. So for that you can see the pandas library, the numpy library, both seaborn and matplotlib libraries for visual representation of the data. Next, you can see that I have imported linear regression model, which we will be using as our base model for prediction. And next is the train test split. That is simply the function where we will be splitting the data into test data and train data. Next, you can see the accuracy score, which is just a metric. And last is our standard scalar. Now this is a class, or I would say this is the function which helps in standardization of the data. Now I'm going to explain in much detail what standardization is, but for now let's just move forward. So you can see that I have set the path to my dataset and reading it, and now storing the data frame as happy underscore data. So using the dot head function, you can see that I have just now printed on my console the first 5 data points inside my dataset. So from this you can see that there are some of the columns. Now what we are going to predict is the ranking, that is happiness rank. And from what we are going to predict is the column that is happiness score to the column dystopia residual. So these are some of the parameters on which happiness ranking has been calculated according to the Happiness Council, and we will also be using that set of parameters also. Now it is given that there's two string data points, I would say columns having data points. Those are country, that is telling you the name of each and every country, and the region where that country is present. So moving forward, you can see that I'm using the dot shape to see the cardinality of my data set. Now you can see that there's only 158 sorry 158 data points having 12 columns in total, from which one is a target variable or the target column. So next you can see is the is null and sum function. So using is null and the combination of sum function, what it is returning me is the value or the sum of number of times a null value was present in each of the columns. So from here you can see that all of the columns have no null values, meaning the data set is pretty safe, or I would say is very good if we are just considering null values. Now I'm not talking about outliers, and I'm not talking about maybe irregular values present in the data. Just for null values, this data set is pretty good. So I've given some pointers just like I told you about, and now we will be discussing something about overfitting. So what happens is that if a data set is very small and you have feeded that model, the data set to the model, so there's a very large or a very big chance that the model might overfit. So the goal of a machine learning model is to generalize patterns in training data so that you can correctly predict about new data. Now, overfitting occurs when a model adjusts excessively to the training data, seeing patterns that do not exist, and consequently perform poorly in predicting about new data. So, just like I told you, since the data set is small, the model tries to extract each and every pattern or all the information it could, resulting in the model actually finding some pattern that is only specific to the training data but not to the testing data or to any new data. That is where overfitting happens and the prediction quality or the prediction accuracy decreases. So how to handle data sets? Okay, small data sets. So we will look at some pointers that can help us in training small data sets. So for all the points that I have mentioned here, it doesn't mean that you have to implement each and every of those pointers. Maybe you can use any combination or maybe just one of them and it might be good to go. So the first is use simple models. Now this is a very vague point, but let me just give you an example of what simple models and complex models might look like. So just like I am using a simple linear regression model, that would be considered a simple model as compared to maybe a random forest regressor, or maybe a I would say that a logistic regression model is simpler in terms or in comparison to random forest classifier, tree classifiers, or maybe SVM classifiers. So like that. So use simpler models because then the model would not analyze over complexly on the data and it won't find some patterns that are only specific to training data. That was my reasoning for the first point. Now the second point is about to be beware about the outliers. Okay, I don't know what I have written. Beware of the outliers. Okay, so here what I'm trying to say is, say there's a column age, okay, age of a person, and now there's a value 335 in it. Yeah, so I don't think there is any person alive that has an age of 335. So I'm talking about data that is well over the maximum range for that column. Because what these type of data do is it confuses the model into thinking that yeah, the column can go till this range, which is not true. So somewhere down the line, it creates confusion for the model and decreases the prediction power of the model. So when I say beware of the outlier, it doesn't mean just look for the outlier and then just leave it like that. What you can do is find all of those outliers, either push them back into a range that is good enough for the column or directly remove all of the outliers directly. The next is select the features. Now this again is very vague, but let me just give you a brief about what you should be doing in selecting the features. Now I have a dataset that has 11 independent variables in it, meaning 11 columns that I have to use for my training of model. Now 11 is a very small value for a model to predict on, and in real life there might happen that the number of columns might run into 2000, 3000, maybe. Okay, if I even go to a lesser extent it would still be till 100, maybe 200. So those are very large number of columns to feed to the model directly. So what you have to do is understand which of those columns are actually important to the data set, sorry, to the model. Which of those columns are very much related or are having an impact on my target variable. Example, let's say that economy, GDP per capita. Okay, this column is actually having a pretty big impact on happiness score. Meaning, if there's an increase or there's a high value for economy or GDP per capita, that means that the happiness score will also be very less. Maybe for a value of 1.2 in the max of 1.6, the value for 1.2 is giving me a happiness score of 15. That is pretty good considering from 158 countries ranked as 15 is very good. So this is what I'm talking about by using the select the features. The next is balance the dataset with synthetic samples. Now, this is a very complex task to do, and unless you have already done this or extensively read about this, you won't be using this. This is because it doesn't just require you having the knowledge about the data set. It requires even more statistical, uh, I would say more statistical and mathematical acuity to use some of those methods that are present in statistics to generate data from existing data. So this is about generating data that is close enough to the existing data so that I am able to increase the size of the data set. So if you want to read about it, you can, but this is not what I would say be a very good way of handling small data sets. Unless you totally understand the methodology that it has and are able to actually use it also. The next is about combining models for final submission. Okay, this is a pretty easy task to do as compared to all of the above. This is because what you have to do is just rather than training one model, train three models. Okay, and take outputs from all the three models and look for the majority. Meaning, let's say there's a class true and false. Okay, now I feeded the model, trained the model, and now the three models are giving me a result of false, false, true. So what does this mean is that the model is now the final submission of all of the three models is giving me a false with 66% confidence, meaning that two are false, one is true, meaning the final vote of the majority, I would say, is false. So we will give the final output as false. So this is what we can do. Now, since we are using linear regression, another thing that we can do is use L1 or L2 regularization. Now, L1 regularization is done or is actually a default parameter or value for the regression model. So unless you try or want to use L2, you don't have to specify anything, which you will be seeing in when I'm trying to build the model. Since for now we're just getting to know about the data, and then next is about fixing the data into a format that is easy for the model to understand or to generalize on. So next you can see is dot describe. So describe function is basically giving me the minimum, maximum, quartile ranges, mean for each of the integral or float value type data. So from here you can see that happiness rank is here, happiness score is there. Happiness score has a minimum of 2.83 and maximum of 7.58. Now standard error has a minimum of 0.018 to 0.136. Now this is also one thing to consider, and after understanding what the problem this or these two columns are going to generate, you might be able to understand why I am using standard scalar class. So see, one has a range from 2 to, I would say 3 to 8, to make it something, a little more easier rather than saying 7.587 again and again. So there's a range of 3 to 8, and then there's a range of 0.018 to 0.13. Now these ranges are very far apart. You might be thinking that these are somewhat closer, because if there would have been a value of 1000 or 2000, so these two numbers won't have even mattered. But yeah, this is why we are using describe function to see the ranges, to see the minimum, the mean for each of the values or columns that my dataset has. And from here, the first thing I am trying to look at is that the ranges for each and every column, are they in a similar or comparable form? If they are, then good enough. We can move forward. If not, then we are going to change the ranges so that they are in comparable. Yeah, so they are comparable. So this is another reason why we are using standardization. Okay, so where I'm actually using standard scalar, I would make you understand how standardization changes the ranges or values so that the data set is in a more, I would say, is in a more fixed manner, from which the model can easily able to identify patterns, and actually those patterns that matter for prediction. So before moving forward, one thing that I told you about was to be beware about the outliers. Now, I didn't really tell you about how to find outliers. I just gave you a brief description of what you can do, but didn't tell you how to do that. So, this is a basic example of plotting happiness rank and health life expectancy. So, you can see that the health life expectancy is on the right y-axis and happiness rank is on the x-axis. This ranges from 1 to 158 since I haven't beautified it, so it might not be visible. So yeah, till 1 to 158. You can see that the pointers stay at 1, go at 0. So you can see that the ranges range from 0 to maybe a little above 1. So from here you can see that there is no value that is going 3, 4, maybe 10 or -5. So you can say that yeah, the data is pretty much manageable and doesn't have any outliers. So again I have given the pointer to understand what I did above. Okay. And next is that I'm directly plotting a box plot. So what box plot gives me is, okay, I've even given a brief description of what this figure is telling me about. Okay, in the box plot, a box is created from the first quartile to the third quartile. A vertical line is also there which goes through the box at the median. The x axis denotes the data to be plotted, while the y axis shows the frequency distribution. And reading this, you might not have understood at all what this figure is trying to tell. So let me dumb things down a little for those who have seen this for the first time. So this is what you call a box plot, and for 4 columns that I'm taking: health, freedom, trust in the government, and dystopia residual. So for these 4 columns, what I'm doing is plotting the minimum, the maximum, the mean, and the median for the data set. which you can see from the graph, where the maximum is this upper horizontal line, minimum is the lower. Okay, this is not the minimum. Yeah, actually this is the minimum and this is the maximum. The box starts from third quartile, goes till first quartile. This gives you the mean value of that column, and what you can see here, these points, is what the box plot has considered to be outliers. So you can see that there is no outlier for the first column, no outlier for the second column. There are a lot of outliers in the third column, like a lot of them, and very few outliers in the fourth. So using this graph, what I'm doing is I see that the third column has a lot of outliers, meaning this is going to disrupt my model and confuse it rather than help the model generalize on the data. So what I'm doing is I'm removing it. Okay, this is what I've done. If you haven't understood about box plot from my explanation, what you can do is go to this link here and understand about box plot and why they are used. Okay, so moving forward again, you can see that just using the head function now my trust column is not present in the dataset. Now I'm just segregating the y or my target variable and finalizing the data. From here I'm also removing region and country both string type data and happiness rank, that is target variable. Next is what we are using our standard scaler. So using the fit transform, I am transforming the data into a manner where each column has a range comparable to each other, and not just range, it actually also normalizes the data in the format that each column might form a bell curve, which is basically telling me that the data is very rich or is going to be very easy to be used. Now again, this might be confusing what bell curve is. So I might want you to look at normalization and bell curve distribution. From there, you might be able to understand more about what a bell curve means. If a data is in that format, why is it so easy or why it's so rich? But before going forward, let me just give you a brief discussion of what standard scaler is doing inside the data. We know variables that are measured at different scales do not contribute equally to the model fitting and learning. Now, this is the reason that I look for comparable ranges for different columns. To deal with this, what we do is standardize the data, meaning that we bring the value of mean to 0 and standard deviation to 1 for each of the columns individually inside the dataset. What this does is that this spreads the data more uniformly and brings the before incomparable ranges to some comparable ranges that now the model can use pretty easily. Next, you can see that for the first row having the first value, after standardization, the value has turned to 1.97. So we had happiness score as our first, and you can see that the value 7.587 is now turned to 1.93. So this is how we do standardization and the reason behind it. Again, to make it more concrete, you can see that I have again built box plots for all the columns that I built before except the trust one, since I've already removed that. And you can see that each and every box plot has either no or very less outliers, and Each of them are having a mean that data is now more spread as compared to before. You can even go back and look at the box plot figure that I built in the above part of the code. Next, you can see that I'm using the train test split function having a test size of 10% of the data set. Instantiating the linear regression class and using the get params. What this returns me is the all the parameters that linear regression class might have or you might want to manually set them up. So you can see that all of the parameters are copy x, fit intercept, n jobs, normalize. So I'm just using the default values for all the parameters and directly fitting the model. So after training, it gives me a training accuracy of 0.98, that is 98 percentile, which is very good. And from the testing, I even get a even better accuracy, that is 99 percentile. So from this, I can say that yeah, my model is not overfitting since the training accuracy is close to the testing accuracy, whereas actually the testing accuracy is even better than a training. And from that, I can say that yeah, I can just directly use this model only since it is giving me such a high accuracy. And yeah, this is the end for the first part of the project, that is building the machine learning model. So I've just saved the model, and now this saved model is what I'm going to use later on in the second part, that is building our web application. So now let's just move forward and go to the second part, that is building web application, where we are building the web application that is on Django framework. Now before we move forward onto the code actually, there are some steps to be followed and let's see those. So you can see that I have enlisted some of the steps that should be followed before running the code or how to set up this code. So the first thing you can see is that I'm asking you to create a project directory. Inside project directory, you're going to keep this code or this web framework application. Next, you're going to build an environment for this project. Now, if you're using an IDE like myself, so what you can do is for PyCharm, you can just go to files and then to settings. And once settings opens up, go to the project and you would see project interpreter. So this is basically asking you to set up an environment. If there is an existing environment, set that up. Or what you can do is click on here and add. So after that, it gives you a prompt and you can build a new environment here. So why I'm asking you to build an environment before even putting up with the code is because this environment is going to hold each and every package or dependency that is required by this code to run. Next, what you're going to do is set up your code inside this directory where the environment is active, and then inside my site directory, so you can see that some of the directories are present here. I built a directory, project directory named happiness rank, and then I set up the code here. Basically, I just put the code inside this project directory, and then inside my site you can see two more directories that are named my site again and polls. So I will tell you where both of these actually came from, what each of them holds. Okay. Next thing is, yeah. So the next thing is to install the packages. Now, I asked you to set up an environment. The next thing you should be doing is actually putting all the packages inside the environment. So for that, you just have to run the command pip install r requirements.txt. So by now, you will be having a directory like this, where this is your project directory, this is my site, again my site and polls. And inside your terminal, you can see that my environment is already loaded and running. And this is my project directory, this is my site. So what I have to do is just type in pip install r requirements.txt. So once I do that and click, sorry, just type enter, this is going to do is all of the packages and dependencies that are required by this code, it is already going to download it and install it inside your environment. So with this, you have set up the code. Now you have to set up the Django framework. So what you have to do is first just type in Python manage.py migrate. So if I type in that, so what this is going to do is that you already have some tables defined in your Django's database. So this is going to instantiate it and maybe put in values that are required by the framework to maybe work in future. So this is what this is going to do. It is going to set up the database, the tables, and if there's any value to be input, then it is going to input that value in those tables also. And once you run this, you will see that db.sqlite3 file has been created. Okay. The last thing is to run python manage.py run server. Now this code is basically telling the framework that now you have to be set up locally and now start working locally, meaning that your web application will now be hosted locally. Okay, so if I run this command, so it will take some time, and if your laptop is a low grade one like mine, it is going to take even much more time. So yeah, you can see that it has started or starting development server at your local host URL. So once you click on it, yeah, once you click on it, you can see that a page has been loaded, and I've already built in form that takes in values so that I'm going to use those values for prediction, and see, it is working. So yeah, now before moving forward, let's go to the settings.py. Now this is located inside my site directory, I would say. See my site, this is outer my site, this is inside my site. And here you can see that the WGSI file and the settings.py file, AGSI files are present. So this is a very important file, I would say, since this is what it is handling and checking for all of the applications, all of the features that Django will be running on this framework or on this project. And the first thing you need to understand is that you can see all of the code inside setting, but if you have just instantiated an project, I will tell you the code for that, then you will see that this is an empty list for you and that the debug is actually set to true. Now since I have already used this code for production, I have made changes in the settings, I have made changes in the app elsewhere also. So this is not the default settings for the Django, but you have to see what all has to be changed before you push your code to production. The first is set up the debug as false. It is already given that security warning, don't run with debug turned on in production. Okay, the next thing to do is set up URLs or DNS, basically telling Django that on what all DNS will this app run on. So this is set up for running the app locally. This is set up for running the app on Heroku. Now I will tell you again later on how this or from where did I get this. Okay. Now next thing you have to do is go till the last and yeah. So Django already creates a static URL where it is telling you that all of the static files are going to be set up inside your static folder. But we again have to manually define which static folder it might be. So for that we are defining static root and giving the folder name as static files. Now all the static files that you can see are defined as CSS, JavaScript and images are going to be amalgamated and then stored inside your static files. This happens when you push your code to production in Heroku. Okay, so this is again we have to define manually. Next, now I won't be going inside detail or I won't be explaining in too much detail about each and every code or subcode inside settings. If you want, you can just go to the docs that are present here and check them out yourself. But what I'm going to tell you about now is how to create a new Django project and how to create apps inside Django project. So if you go back to your flow.txt, you would see that there are two codes here. One is telling Django admin start project name of the project. So this my site directory was actually created by Django and not by me. And all of the things inside this directory was already pre-initiated. All I did was maybe create some new files or append the pre-existing files. So see, Django already gives you a base on which you can work upon. You don't have to code from scratch. And all of the security settings, again, you don't have to worry about those things. Django takes care of it on its own. So what I did was I wrote Django admin start project my site. So it gave me a my site directory inside which all of my files and folders are present. Now the next thing what I did is I went inside my site directory in the terminal. Then I wrote python manage.py start app name of the app, that is polls. So what you can see here is app. So polls is an app, but my site is a Django project. Okay. So inside my app, you can see some files, views, URLs, admin app. All of these were pre-initiated. These happiness model and happiness scalar are actually the standard scalar and linear regression models that I stored or saved from my first part of the project. Okay, now let's move to views. Yeah, so views for an app is particular. Like in dictionary, for one key there can be only one value. Likewise, in an app, for example, polls, there will be only one views. And inside views, this is the place where rendering of pages occur, or where manipulation of data occurs, or where storing of data into databases occurs. What I'm trying to say is that see there's a okay, yeah, let's go in this way. See, this is a function that I've created, taking an parameter as request. Now, just excuse this part and see what it is returning. So it's using a function render, taking a first parameter as request. Second is index.html. And third is context. For those who don't understand about context, it is basically a way that I am trying to send data to my pages. Okay, and not just data, it can be metadata also or some other kind of data. that I want to show on the page, or maybe that I want to use on that page, or something like that. So you can see that the index.html is actually my HTML page, which this function is rendering. Now, the work of this function is not just to render the pages, but also use the data that it has got from the page. What I mean to say is, just like I showed you the page when I used the Python manual.py run server. So this is my HTML page where the form was created and where the form would be filled up also. And now once I click on submission, okay, so all of that data flows into my view here, okay, and now all of the data is now being stored in different variables that I've already defined, and then those variables are used to create a data frame. Okay, you can see that a data frame has been created here, and that data frame is given to the standard scaler to transform that data into a standardized data. So I've set up my standard scalar object here and use the fit transform to standardize the data. Once standardized, I'm feeding that data to my model for prediction. Okay, then I'm returning, or I'm storing the value here, my result, and sending the result to the page, which is then shown using this part of the code. So with this, we have already set up and understood the basics of how the Django framework is working, and how the page has been rendered, how the data from the page is going in the backend, stored or maybe manipulated, then returning to the front end and shown here. Now, one thing to understand is that this is not your typical function, meaning that Django has already set up a flow of how functions are to be created. If you are inputting request as a parameter, then Django itself understands that this function has to be used for some page, meaning that this function is going to render some page, and it can be a static page or it can be a page where data has been stored or is wanting to be stored. Okay, but if you create an function which is not taking request as a parameter, then Django will understand that this function is not associated with any of the pages, and this function is most probably a helper function to one of the functions that are associated with some pages. Now, one thing another that I have to show you is about URLs. So here I have set the first, okay, this is telling Django that on which URL which function has to be run, so that a particular page will be rendered on that URL. So since this is an empty URL, it tells that at this URL you have to run the first function from your polls app, and in the views, once the first function is run, it will understand that you have to render the index.html page. So this is how it works. With this, I'm going to finish the second part of the course or the project, that is building the web application. This is more of a setup of web application and how to run it. But yeah, with this, we are going to complete the second part and move over to the third part, that is deploying this web application to Heroku. Now in third part, I'm going to tell you about some of the files that we have to create and are not preset or pre-built by Django, because those files are actually required by Heroku when it is setting the code in server for production. So this is the third part of the course, or the project where we will be deploying our web application on Heroku. Before we start off with Heroku, we have to use some files or create some files which are like commands for Heroku to understand. So let's start with runtime.txt and proc file. Runtime.txt is basically just telling Heroku which language or base is to be used by the server. Procfile, on the other hand, is the mechanism for declaring what commands are to be run by your application in Heroku platform. So you can see in Procfile, we have defined just one line telling that Unicorn has to use the WSGI file from my site directory and run those commands that are I'm going to specify. So the commands that I updated you on last video, which was about the second part of the course or the project, like the Python manage.py run server or Python manage.py migrate. So these commands are executed in Heroku server using the proc file. Now, moving forward, what you have to understand is that Heroku, having its server, doesn't automatically deploy the code without doing much about anything. It needs both of these files, and with this it also needs a requirement.txt file to download and install all the dependencies also, like we did in the second part of the project. So whatever we did there is something similar to that is done by Heroku, that is automated. Okay, so once we, yeah, let's just jump on to Heroku itself. But before going there, let's go to the GitHub. Yeah. So in GitHub, you have to first upload your code to some of the to any repository. Okay. And just remember the branch of that repository. So I just built an happiness ranking repository and uploaded my code. You can see the code here. My site, polls, proc file, manage.py file, requirement.txt file, runtime.txt file. Another thing you would be able to notice is that once you deploy your code on Heroku, it would show you that there's an environment set up for you and that the environment or that the app is active. So let's go to Heroku now. So once you log in, you would see your dashboard and maybe there might not be any apps present there. Since I've already built 3 apps, so yeah, what you can do is click on new and click on create new app. Just put in any name here which is accepted by the by Heroku and any region. It only gives you two options and then click on create app. I've already created an app for this project, that is happiness ranking. So once you click on that, see on the dashboard your app would appear. Just click on the app and you can see that it has given you some options. And the first thing you do is go to settings and click on add build packs. Now select Python and then click on save changes. Once you do that, you would be shown a Heroku/Python build pack is now instantiated for this app. Then what you can do is click on open app. Now this might take a little time to load, but for you it won't be showing this page. Since I've already set up the app, it is able to show me or render me my actual template. But what I wanted to tell you about was that once you click on that open app, a default page generated by Heroku would be shown to you, and you can just copy this, okay, and then go back to your code and change it inside your settings.py file. So this actually came from open app here. Okay. So again, Once you have done that also, go to deploys. Now in deploys, it gives you three options for deployment method. We are going to use the GitHub Connect. Okay. So once you click on this, it would ask you to set up your credentials or give your credentials. So once you log in into GitHub, it would say that the GitHub is connected, and it would here show that now once the GitHub is connected, you have to connect any one of your repositories with this Heroku app. So where I'm getting a disconnect option, you're going to get a connect option. So once you click on that, or before even clicking, it would give you a search bar to search some of the repo. So once you choose the repo, you click on connect, and after it is connected, it's going to show you something like this. Now we skip on to manual deploys. Okay, this automatic deploys are for those who know how to build CI or CD. So in manual deploys, what you're going to do is choose the branch. Now I ask you to remember the branch in which you have uploaded the code. Since mine is in master, I'm going to choose master and then click on deploy branch. This is going to take some time as the server is now getting sorted out, and then all the code is settling in with all the requirements, or I would say the packages and dependencies getting installed. So here you can see that it has now taken the build. Oh my god! It has taken the build pack Heroku Python, and then it is taking the version from my runtime.txt. Now it started to install all of the packages using the requirements. After that, it has run another command that is specific to the Django, that is python manage.py collect static. This is basically telling the app that you have to store all of the static files inside one directory, that is static files directory. So you can see that also here. Now it has compressed and done all of the work that it has to for the server to get set up and use the code. And once it has done that, it has now saying that it is launched. So if you get a view button, that means that you have successfully deployed your code, and you can just click on view, and it will take you to the page, the main page that is going to be rendered on this URL. So I can take in just India, maybe region Southeast. Okay, this is not going to be, yeah. I'm just filling up the form with random numbers. Okay. So once I click on confirm submission, you can scroll back and see that the happiness rank given for India with those values, particular values, is rank 79 out of 158 that we used for training. So with this, the third part of the course or the project is also completed, and now we have actually deployed our web application on Heroku. Thank you.